recording this. When you close this circuit, the switch, what happens in the circuit? Okay, once you close the switch, since you start the current that flows through both the capacitor and 3.6 mega ohm resistor, the let's say this plate is positive and this plate is negative. Okay, so when you close switch at time t is equal to 0, the current first will start flowing in this direction. Let me label this current as I. So there's only one current, of course, because there's only one branch that connects this capacitor and resistor. Over here, this is the current again, I, the same current. So our aim is to write down equation for this current. Well, for this current, as I said, this current is going to be maximum as time t is equal to 0 when you close the switch. You can treat the capacitor as an 80 volt battery. Okay, let me write this initial potential difference V0 to be 80 volts. You can just view the capacitor as an 80 volt battery connected to a 3.6 mega ohm resistor. So at time t is equal to 0, this current is going to be maximum value, right? Because it has a maximum voltage, as you see, as time goes on, since the charges on the plates of the capacitor will decrease. Initially, it is at maximum value, so that the potential difference is 80 volts, while the current is flowing, neutralizing these charges as time goes on exponentially. Obviously, at any time other than time t is equal to 0, the potential difference between the terminals is going to be less than 80 volts. But when it is 80 volts at time t is equal to 0, the current value will be maximum. And the maximum current, let me write down the maximum current, or I0, the current at t is equal to 0, is going to be just, 80 volts divided by this resistor, 3.6 mega ohm, means 3.6 times 10 to 6 ohms. I'm writing this because I'm using just Ohm's law. The resistor multiplied by I, it will give you the potential difference. Well, this potential difference, the initial potential difference, which is 80 volts, is also the initial potential difference between the terminals of this 3.6 mega ohm resistor. So by just solving this, you can just find what the current on this simple circuit at time t is equal to 0, when you just close the switch. At that time, you read the current value in your ampere meters to be 80 divided by 3.6 times 10 to 6. Mega is 10 to 6, So, since we already found the initial current at time t is equal to 0, and we know that this current value will drop to 0 as time goes on exponentially, you can just write down the time dependence of the current through this simple circuit to be I0 multiplied by the exponential to the power minus t divided by tau. And you know this. If you don't know this, what this is, or you don't have any idea why I did this, why I wrote this equation, just refer to my discharging capacitor video. Okay, how did we find this expression for time dependence of the current in a discharging circuit? Also, I explain this in a charging circuit in my videos. Okay, just refer to that. So this is the equation, time dependent equation for the current that flows through this specific circuit that contains a 16 microfarad capacitor and 3.6 mega ohm resistor. But what is time constant? Tau. For this circuit, we know that the time constant is nothing but the capacitance value multiplied by the resistor, R times C. The resistor value multiplied by the capacitance value. So this is 3.6 times 10 to 6, 10 to 6, multiplied by 16 microfarad. 16 micro means 16 times 10 to minus 6. And this is going to be obviously, this is 10 to 6 multiplied by 10 to minus 6 will give you 1. And 16 multiplied 3.6 multiplied by 16 seconds. Well, the unit for the time constant is just seconds, okay? If you multiply ohm by farad, you get seconds. So this is your time constant, tau, and this is going to be put over here in this equation. When you know what I0 is from this, and you know what tau is from this, the rest is just for time dependence. The rest is just, you know, what is going to be I, or the current, at a very specific time, at any time in fact. If you put the time is equal to 1 second, you can just calculate the current that flows through this circuit at time is equal to 0. You can calculate it by using these equations, by using these numbers. Instead of I0, you put this number, and instead of tau, you put this number. At time t is equal to 1 second, you just put t is equal to 1. So that's it. The question is, what is the current value? Sorry, what is the voltage value at time t is equal to 40 seconds? Well, this was the current equation, but the voltage equation is just the same. The voltage across the capacitor or across the resistor, because whatever you read from the voltmeter across the capacitor is going to be the same value for the voltage across the resistor, because they are connected to each other, right? The voltage value for both the capacitor and the resistor is going to be the same. So the voltage equation for the discharging circuit is nothing but just in the same format. Instead of V, we use I. Instead of I, we use just V. V0 multiplied by this exponential factor minus T divided by tau. So what is initial voltage? It's just 80. And what is tau? It's just 3.6 multiplied by 16. And next is, well, whatever the time value you want to calculate for the voltage is, just put this time value. But the question is asking, what is the voltage at time t is equal to 40 seconds? So the voltage at time t is equal to 40 seconds is just, instead of t over here, you put 40 minus 40 divided by 3.6 times 16 to the exponential factor multiplied by 80 is the answer to this question. Okay. Do you have any questions for this?